Hello friends, welcome to IS at Speed of Light, and today again we are going to continue with the physical geography concepts. And the first thing which we like to discuss today is about the cyclones and the anticyclones. So we need to focus on the basic principles which involves in cyclones or anticyclones. So in case like if next time you come across any cyclone, the any tropical cyclone by the local name in your newspaper, you should be able to identify that, and you should be able to relate it with the basic concepts about the cyclones and the anticyclones. So as we have already discussed, the cyclones, the first thing is they're the low pressure at center. So it's very simple. If you have a very low pressure at the center, and less the pressure is, the more higher would be the velocity of the winds which are going to blow towards the center of low pressure, right? The steep the gradient of the pressure will be, the more would be the wind velocity. So that is what happened with the cyclones. They get very low pressure center, which got developed at the center, also known as the depressions, so that violent winds are going to blow inside that low pressure. This is the first point which we need to understand about the low pressure cyclones. Now, second is these cyclones, they are known by different names in different parts of the world. For example, they are known as typhoons. Typhoons in South China Sea, which is actually Pacific Ocean. They're known as hurricanes. Around Caribbean islands, in Atlantic Ocean. They are known as tropical cyclones around Indian Ocean, that is around our Indian subcontinent. So these are the different names of the same principle of the or of the same concept, the cyclones, the typhoons, the hurricanes, the tropical cyclones. These three actually only differs in intensity, duration, and locality, and not in principle. So please make a point here. It differs only in case of differs only in locality, the place where they take place or where they originate, their intensity. So they may be of different intensity. And their duration, the duration for which they will be active. So last time in mains 2013, they have asked a very straightforward question like how these tropical cyclones get their local names. So I would like you to search for that in the newspapers, in the Hindu or maybe in some any good newspaper, on how these different cyclones get their local names. For example, we say Katrina cyclone, or in India we said it like Lala. Tropical cyclone, like how these tropical cyclones get their local names in different countries in their local language. So this was the direct question which was asked in the mains 2013. Now the third thing which we would like to remember is the precondition for the formation of cyclone is the surface water temperature of the ocean should be more than 26.5 degrees centigrade. So it has to be warm and humid. So this is the precondition, warm and humid. If we want good precipitation, heavy precipitation, or storms, or the anything related with the severe weather condition, it has to be warm and humid. So that is how, because of this particular fact, this phenomena of cyclones we don't see in Arctic Ocean or Southern Ocean, because the water temperature is much less than this. This phenomena we don't see in Arctic Ocean and the Southern Ocean. Another thing which we like to remember here is their movement. Cyclones, they move in anti-clockwise direction in northern hemisphere and clockwise in southern hemisphere. And the reason is, I think, very obvious and it's clear to you. It is the Coriolis effect. The rotation of Earth is causes a deflection of the winds towards right and towards left in southern and the northern hemisphere. So these are the different things about cyclones which we need to know. And the moment now you come across any new cyclone getting developed either in the Pacific Ocean or either in the Atlantic Ocean, you have to associate these principles with them and not more than that. Right. So because of the Coriolis effect, what happens, as you can see in this figure, the air would rise up and it will deflect in a particular direction around the low pressure and the high pressure. High pressure in case of anticyclones. So cyclones, we normally associate it with the severe weather conditions, right? So violent winds will blow, heavy rainfalls, heavy thunderstorms. So severe conditions. Now, opposite would be the case with anticyclones. So, anticyclones, we are going to have a high pressure in between. Now, what next will happen if it's a high pressure in between? Winds are going to flow outwards from the high pressure to the low pressure. So, this is the basic concept. And these anticyclones are normally feared weather phenomena. Normally, severe weathers are not associated with the high pressures because it's a descending air. Fair weather phenomena. Okay. And another thing what we can remember for anticyclones is their movement. Contrast in with the cyclones, they have clockwise direction in northern hemisphere and anti-clockwise in southern hemisphere. So cyclone actually it was a Latin word which meant wheel. So in this, what happened? The air is going to move like as a wind, like as a wheel, right? Rises for the cyclones, descending for the anticyclones. So this is what actually we require to think about logically for cyclones and anticyclones. We will try to go in much depth of that when we are going to study these geographical phenomena along with the case studies when we will study in depth about the physical geography. Let's move ahead now to another very important topic for the UPSC. And if we analyze last 20-25 years of question papers, we find on an average one question have been asked every year from this different climatic zones. So it becomes a very important topic for UPSC. And we have to follow a very balanced approach toward this particular topic because there are almost 10 different world climatic zones. So how to go about all these 10 world climatic zones? If we analyze last year papers, they are particularly focusing on the typical features of that particular zone, okay, the climatic zone, and not too much in detail about that climatic zone. So we have to follow the same approach as UPSC has been following, the typical features of the climate zones, and we have to go by logic, like whatever we have studied till now. For example, the movement of the sun, how it varies with the seasons, and how it brought summers in the northern hemisphere and winters same time in the northern hemisphere. More elevation most of the times means more evaporation, more condensation, and then more rainfall. The difference in climate between the places which are near the seas and which are away from the seas. So these are some of the very basic concepts which actually we are going to apply and learn about the different climatic zones of the world. So this division, this whole division for the world climatic zones, we do on the basis of three principles. First is the difference in temperature. Second is the difference in precipitation. Now these two factors combining, the temperature and the precipitation, will give rise to the natural vegetation. So we have to study three parts: the temperature, the precipitation and the natural vegetation. Now the first thing which should come in our mind right now is how the temperature is going to vary for the whole earth. So the obvious answer is, as we go up from the equator to the North Pole or to the South Pole, we are going to have a cooler temperature, right? So this is the first thing. So that is how we are going to start our discussion on this. And as we move up from equator to North Pole and South Pole, we are going to experience different climate, and that is how we are going to define the climates. Let us start now with the first climatic zone, and which is between the 0 to 10 degree north and south of equator. So if this is the equator, so this whole region is going to experience this particular type of climate. Let us mark here, like whatever we are saying. This is the South American part. This is the basin of the Amazon River, right? Around Africa, we see this particular portion. Then we get the East Indies or the East Asian countries like Malaysia, Indonesia, so these all places which are around between the 10 degree north to 10 degrees south. So these are the areas for the hot, wet, equatorial climate. Now let us put some logic behind this, how it is going to happen. Now the places which are around equator, the first thing which should come into our mind is how the sun is behaving for this part. So sun is directly overhead equator like most of the times in a year. So these are going to be hot areas, right? These are going to be the hot areas. And another thing is they are all near the oceans. They are all near the oceans. And what condition we put with these areas? If they are near the oceans, they are not going to have a very extreme annual range of temperature, right? The difference between the summers and winters will not be much, right? This is the second condition. And the more hot it is, right, the more it is close to the sea, the more evaporation, the more condensation, it is going to be a good rainfall, right? So it's going to be a good rainfall throughout the year. So these are the basic three things which we can derive logically the moment we know the area or the moment we know the latitudes of that place. We can say that. Let us go ahead and see different points which we need to remember for this area, and it is better to keep focused approach on this particular session and not going in too much depth. You can definitely go to the Gishing Long about the different human activities with what they have given, the different plantations what they have given, different vegetation what they have given in their world climatic chapters. So the point number one is going to be the lowland versus highland. Now even in this particular area what we have marked here for this climatic zone, there is going to be a different variety of temperature. The lowland versus highland, we clearly know that as we have a highland, if we go on the top of a hill, we are going to have a much cooler temperature than the lowland. So even if in countries like Malaysia, the Kuala Lumpur and or the Cayman Islands, if we compare these two places, we are going to experience the different temperature or different climate. So that is the point number one. We should understand the lowland versus highland concept. So even if they are on equator, if it's a highland, we are going to experience a much different climate in lowland and the highland. Uniformity in temperature. This is the second point, and which is also very well understood now. We are going to have a uniformity in temperature because of the closeness with sea. Closeness with sea. So now if somebody is going to give you some temperature table, and if they would say you please find out the climate zone, so if it's a uniformity in temperature, like if there is not much difference, there is no distant winter seasons, so that is going to be, it can be equatorial regions. Point 3, heavy precipitation throughout the year without any dry season. We have already discussed that there has to be a good rainfall throughout the year. So there is no dry season. So we have to keep this in mind. Heaviest rainfall in the months near to equinoxes. This reason is simple. As we have discussed, during equinoxes, uh, sun's rays are on equator, right? Sun rays are on equator, so it's clear if sun rays are direct on the equator, they are going to be more hot, they are going to be more evaporation, leading to the more rainfall. So more rain in the months of equinoxes, and the reason is very simple for that. Here again we see conventional and the orographic rains. Orographic actually simply means if there's a hill and there's a wind coming here, it is obstructed by this hill. So this hill, what it will do is it will forcefully pull it up. Okay, and when this water or water vapor air, when it's going to pull up, it's going to condense, and when it is going to condense, it is going to rain. So this is the simple meaning of orographic rainfall. So actually we define three types of rains. The first one is the conventional rains, where it's going to evaporate, it's going to condense as a cloud, and then it is going to rain. This is the conventional rainfall. Orographic rainfall we have already discussed. When the rain is pushed up by the obstruction of a hill, it's going to move up in the air, the temperature gets lower, it condense, and then it rains. This is the orographic thing. And third is, last time what we have discussed, the frontal push, right? The frontal push, like this is the cold air mass and warm air mass. So here the warm air is getting pushed above the cold air mass. So this is known as the frontal rainfall. So these are the three types of basic precipitations, and very easy to understand as well. So relatively high humidity, right? It's going to be a very humid environment. Why? It's simple. You have high temperature, right? If you remember from the last lecture, the surface area of the air parcel would become more. The water vapor becomes less. That is the relative humidity. So it's going to have more evaporation, right? So it's going to be a very moist environment, right? We are going to sweat a lot. I mean, in with summers, if we see it's high humidity, we used to sweat a lot. Point number 6 is a tropical rainforest. So tropical rainforest, these are the evergreen forest. Evergreen forest, and evergreen forest, as the name suggests, they would be found in the place where you find empty rainfall, right? Ample rainfall, good rainfall seasons. So all year around growing seasons, right? Tropical countries import timber. So these countries, what we are talking about, which have this equatorial climate, which have these rainforests, they are actually the net importer of the timber. There is a reason for that, because the commercial export or the commercial extract of these timber is not so much possible in these countries, and the reason is two. The first reason is, in the rainforest, right, in the evergreen forest, there are so many species in the same area, so it becomes really difficult to choose. Like if you go to the forest and you have to cut a particular hardwood, but they are distinctively placed in that particular forest. So first is the different varieties of species, the different species in the same area. And the second point is, these hardwoods, okay, these timber, it's doesn't float on rivers, okay. So what happens is, if it don't flow in rivers, transportation becomes really difficult. So that is how the tropical countries, in spite of having great potential for these forest timber, they actually are the net importers for timber. The famous product for these tropical countries, it is a natural rubber. So Malaysia and Indonesia, the East Indian countries, what we have seen, they are the leading manufacturer of the rubbers. And another point here is the poor soil. So we can first think like these other rainforests, they should have a very good soil, right? And yes, they have a good soil because they have lot of leaves, they have lot of humus which is coming from the trees actually. But what happens is when there's lot of rainfall, rain is going to flow away with these soil nutrients. So that is how it's actually a poor soil, if you say. And this particularly happens only when, like, I mean, people interfere in the working, like people cut the forest, use this natural fertile soil for their vegetation, and then again they move towards the next patch to clean the forest and again do the farming there. And what happens this time is when it's continuously raining, then this rain actually will deteriorate the soil humus or the soil nutrients. So it has both a poor and a good soil. If there is no human interference in that, if humans are not cutting the forest for their farming, it's going to be good soil. There would be good reproduction of the forest. While if there is a human interference when they are doing the farming, it's going to be a poor soil because of the continuous downpour of rain. So this was the first division around equator, right? Around equator. Now let us move one altitude above, and if this is the equator, we are going to move now between 10 degrees north to 30 degree north, and similarly 10 degrees south to 30 degrees south. And let us mark the regions which actually give this. So it covers whole of India. It covers the southern China. Right. So this is a region for the tropical monsoon climate. Now we know like what happens in India, how this tropical monsoon works. We have a three distinct climates, right? The summer climate with the rainfall, and a particularly dry climate with very rare rainfall in winters. So three distinct climate seasons. It's summer, monsoons, and winters. Now again we will follow the same logic. Sun at Tropic of Cancer. When sun is at this point, it's going to be summers for the northern hemisphere. It's going to be the summers for this region. When sun at the Tropic of Capricorn, it is going to be winters. Now what will happen is with summers here, with the sun shifting the axis, and with it the ITCZ, right, what we studied, the intertropical convergence zones, it also shifts its belt towards the north in the summers. It's going to be intense heating of this region, particularly the Tibetan Plateau and the Himalayan region, setting up of low pressure here. And similarly, that time when the southern hemisphere is facing its winters, right? Because the sun is in the northern hemisphere now, it's a high pressure here. Right? It's a high pressure here. So that is how the low pressure and high pressure games start, and there is a southwest monsoon in Indian subcontinent. And when the things reversed, when there's a sun directly over Tropic of Capricorn, it's a low pressure here and it's a high pressure here. Again, we see the retrieval of monsoon. So this is just one factor which actually influences Indian monsoon. There are some other factors also like El Nino and all, which we are going to discuss in separate sessions, and some very easy concepts, not very difficult. So sun at Tropic of Cancer, summers, sun at Tropic of Capricorn, winters. And now forests are going to directly proportional to the summer rainfall. When you have a dry winters, you need to have deciduous forests. So deciduous forests are the one which shed their leaves during dry season. During dry season. So that is what we maximum find in the Indian environment, the deciduous forest. And teak is the famous deciduous forest tree, which is known for its hardwood. So forests are directly proportional to summer rainfall. So wherever you find more rainfall, we are going to find more forest. Now the second regions which we want to define in this 10 degree to 30-degree north and south, it is the marine climate, right? So let us mark that marine climate. Madagascar, Australia, northern part of Australia. So here, if you see the northern Australia, this part, it is having the monsoon influence, and this part is going to have a marine influence. So the only difference between the tropical monsoon and marine is these are the marine environment which don't have any distinct dry period, right? Don't have any distinct dry period because they are actually very close to the oceans, seas, and that is how they are going to get most of the times good rainfall, and also they are under the direct effect of the trade winds. Trade winds, right? And this area more prone for the tropical cyclones, typhoons, and hurricanes, as we have discussed, right? So these tropical cyclones we normally find in the region of the 6 degree to 20-degree north and south. Now, how you will catch this question in UPSC? The first thing what you have to see, if they are talking about the monsoon climates, there has to be a tendency of summer maximum, right? The rainfall which is maximum in summers and consequently decreasing in winters or becoming almost zero in winters. They are going to have three distinct climates, so there would be a difference in the temperature also. There will be significant difference in the temperature between the summers and winters. And if they are going to talk about the tropical marine climate, they are going to have uh, more rainfall in summers, no doubt, but there will be no dry season. And these things will reverse actually. If you say in southern hemisphere, the same things will be applied for the winter season as the things what we are applying for the summers in the northern hemisphere. Let's move ahead to the region 2 of the same latitude, that is the 10 degree to 30 degree in north and south. Let us mark it on the map. So this environment is actually particularly developed really well in the southern Sudan region of Africa. That is how it got its name. So it covers a good part of Africa, the Savannah or the Sudan region. And also the south of the North Australia, what we have seen, this was the monsoonal region and this was the marine region. Now this we see Sudan or Savannah region. Now this, if we say it is a transition between the monsoonal lands and the hot wind, the trade hot wind deserts, right? So this particular latitude we are going to define three regions, the 10 degree to 30 degree north and south, three regions. The first is the monsoon region, which is important, keeping aside marine region. The third is the savanna region, which is actually now the interface, the transition between equatorial rainforest or the tropical region to the hot deserts, right? Hot deserts we are also going to see in the same latitude, the 30° north and south. Let us see the important characteristics of the savanna or the Sudan climate. So it is the transition between the equatorial forest and the hot deserts. So it's going to have the in between characteristics. What it mean to say, it is going to have in between characteristics. Like in hot deserts we are having very less precipitation, equatorial forest we have a good amount of precipitation. So here it would have a mild precipitation only in certain months of the year and not throughout the year. So second point is it is hot rainy season and cool dry season, very important, right? So hot dry season, hot and rainy season. So it's going to be rain in the summers and cool dry season, that is no rain in winters. 90% of times we will see this same pattern when there are going to be no rain in the winters, because winters, if we say it's a high pressure season, right? So normally we won't find any rain in the winters because it's a high pressure system. The air is going to descend now and not rise up and rain in summers. Now things now will change in northern and southern hemisphere, because if you see for the southern hemisphere, when January, if you consider, it's winters in the northern hemisphere, but same January it's summer in the southern hemisphere. So that is how we need to be careful when we talk about the northern hemisphere and the southern hemisphere. So this particular question have been asked in IAS 2012 prelims. The same question they talked about the season of the savanna. So savanna, the first thing is savanna is a tropical land, okay, the tropical land between 10 to 30°. So it is going to have a hot season definitely. So rainfall in summers, and there is going to be no rainfall in winters. And again we know one more thing about savanna is the transition between the equatorial, so there is not much rainfall throughout the year, right? So this question have been asked in IAS 2012 prelims about the uh, uh, season which climate which best define the savanna region. So annual precipitation is going to be less than tropical monsoon season, we have already discussed. High temperature and an annual difference of around 20 degrees, right? So high temperature, it is understood because it's tropical region, and annual difference is going to be of around 20 degrees, annual difference between the summers and the winters. Another thing is which we like to remember for the savanna region is it is the region of tall grasses with short trees. So not completely grassland. So this is a picture like from savanna, and it is the famous places like where film shootings take place around the wildlife sanctuary. So it is a place which is very famous for the wildlife, African wildlife. So these are the important points about savanna, and most of it are logically derived, right? So this 10° north to south, we started with a monsoonal regions like India. We know about India. It lies between this latitude only. So tropical monsoon, then tropical marine certain regions. Then we moved a bit ahead to the savanna region where rain is a bit less. After that savanna, now we are going to move to the deserts. These are the hot deserts of the trade winds belt. These are the markings of the great deserts. So starting from here, the North America, we have the Desert, Mojave Desert. Then you have here the Great Peruvian Desert or Atacama Desert. This Atacama Desert is the driest desert of the world. Then you have Patagonian Desert. Then you have the world's biggest Sahara Desert of Africa. Then you have Kalahari and Namib Desert. Then Arabia, you have Turkestan Desert. You have Gobi Desert. You have Thar Desert, the Great Indian Desert. And then you have the Australian desert. Now here if you see, we can divide these deserts in two parts. The first are the one which are around the Tropic of Capricorn and Tropic of Cancer, which are around the tropics, right? And the second are the temperate deserts, right? Like the Gobi Desert, it's a temperate desert. Turkestan, Turkestan, and Patagon. So these three deserts, the first one, the second one, and the third one, we define in the temperate region, and other are in the belt of the tropics, right? So Australian desert, the Great Australian Desert, this is the second greatest desert after Sahara Desert. So there are two types of desert. One are the tropical desert, and other one are the temperate deserts. So one particular feature which we can note about these deserts is the tropical deserts, they are on the western parts of the continents. If you start from here, western part, this is western part, this is western part, the Sahara western part, Australian desert western part, right? So all these deserts lie on the western part of the continents, while temperate deserts like the Gobi Desert or the Turkestan Desert, they lie interior to the continent. They lie in the interior parts of the continent. So if they lie on the interior part of the continent, the first reason which we can think of is like, because when the rain bearing winds, they come from the oceans, the time they reach these places, interior of the continents, they become dry. So interior of the continents is the reason for the temperate deserts, apart from this Patagonia desert, because this actually lies on the leeward side of the Andes mountain. So you have westerlies, so westerlies they flow like this, but you have Andes mountain. So this Patagonia desert lies on the leeward side of the Andes mountain. So this is a basic classification of the hot deserts. Uh, we divide it into tropical deserts and the temperate deserts. So tropical deserts, we find them mostly on the western sides of the continents. This question have been asked 2 or 3 times, like why actually most of the hot trade wind deserts lie in the western part of the continents. And please remember the winds, right? So here when we talk, it's a low pressure and it's a high pressure, so we say it's a trade winds, right? And our that we have westerlies. So please keep these things in mind. The wind builds for that particular latitudes. So hot deserts, we have offshore trade winds. So here again there is one term, offshore and onshore. So it simply means if this is land and this is water. So offshore means the winds which are going away from the land. So these are the offshore. And if they are going from the land to the sea, they are not going to have any moisture, so there will be no rain from these offshore winds. But in contrast, if you have winds from the ocean towards the land, they are going to be onshore winds. So there are chances like when it is coming from the ocean, it will bring moisture from the ocean and it is going to produce rain. So simple concept. So offshore trade winds, all these hot deserts, if we see on the western part, they lie on the belt of trade winds. Okay, so trade winds, these are the offshore trade winds. So the winds which actually reach these hot deserts, they, because of their location on the western part, they once they start, these trade winds starts from the ocean. By the time they reach these deserts, it's completely moistureless, right? And they have offshore, like they have winds from the land to the ocean, so there is no possibility of the rain. So hot deserts, because of the offshore trade winds. The temperate deserts, as we have discussed, those three or two deserts, which are deserts because they're interior locations in the continent. So majority of the hot tropical deserts are on the western coast of the continents. The question comes now, why on the western side of the continents on subtropical belt? The first thing which we should note now is it is a subtropical belt, and the subtropical belt is a high pressure belt. So high pressure, it means descending air, right? The air which is going to sink, and the air which is going to sink, it's not going to produce rainfall. So reason one, it is a high pressure belt. So descending air, there is going to be no rainfall. So rain-bearing trade winds blow offshore. As we have discussed, the rain-bearing trade winds blow offshore. Another reason is the cold current. The cold current actually which flows through this. Let us take an example for this. This is the Atacama Desert, right? This one is the Atacama Desert. Now, one cold current, the Peruvian current. The Peruvian current actually blows uh, around this Atacama Desert, and we have said it is the driest desert of the world. Now, how this Peruvian current is going to influence the dryness of this desert? Actually, what happens if I am going to have some moisture bearing winds coming towards this desert like this? Okay, and let us go to some other diagram and let us show there. So this is the Atacama Desert. This is the Atacama Desert, and you have the Peruvian cold current flowing like this. Now what is going to happen here now is, if suppose there are some moisture bearing winds which are coming in this direction, so these are the moisture bearing winds, but this is a cold current. Now what this cold current would do is it would condense this moisture. So by the time they will reach this desert, these winds won't have any moisture. And this phenomena is known as the desiccating effect. Desiccating effect of the cold currents. So the cold currents also play an important part for the location of these deserts on the western coast of the continents, western coast of the continents of the major part of the world. So it becomes a really important question. In mains also 2013 they have asked a similar direct question like, what is the reason for the location of these deserts, the subtropical high pressure deserts on the western parts or the western coast of the continent? So reason is simple. The first one is the offshore trade winds, right? So offshore trade winds, and second is the cold current, the location or the movement of the cold currents around the western coast of the continents. This is all about 10 to 30 degree north and south, right? We started from the equator, and you have to catch the UPSC questions like this only. You have to find the typical features of that climate. For example, in equatorial regions, we saw it's going to be a uniformity in temperature. Like if you go to Mumbai or Chennai, there won't be any difference, much difference in the winters and the summer climate, in the temperature of the summers and winters, because of their location, which are very nearer to the sea. Same thing happens with the equatorial also. There has to be rainfall throughout the year. There has to be uniformity in temperature throughout the year. So that is how you are going to catch the question. Similarly, for the monsoonal seasons, between 10 to 30 degree north and south, it's going to be three different seasons, and rainfall will be concentrated in the single season and not in the whole year. We saw the marine environment also, the tropical marine. After that, savanna becomes really important for the exam. So savanna, again we saw it's a transition between the hot deserts and the tropical monsoon. So it's going to have the mist characteristics. It is going to have rain, but which is going to be the less than monsoon rains. And it is going to have a dry season, a definite dry season in the winters, and definite wet season in the or summers, and this thing also will differ with the north and the south hemisphere. Like north hemisphere have their summers in different months, and southern hemisphere have their summers in different months. So now we will finish here, and next time we are going to start with the different other climatic zones, and we are going to finish it, and we will also see the different questions which have been asked in UPSC from this climatic zone part. And don't break too much of your head into this. Just understand the basic logic, right? If you understand the basic logic, how they are distinguishing different climatic zones, the questions which will come in UPSC, you can attempt them really well. So don't try to mug up these things. These are just based on the concepts which we have already studied. Now next time we are going to start with the 30 to 45 degrees altitude, and this is the temperate region, the warm temperate region, and we are going to start with the Mediterranean region. And Mediterranean region, again, one of the most favorite for UPSC. So thanks for tuning in. Watch the next lecture for the different climatic zones.